Hey everybody, this is Larry. This is day 6 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's poem. I still gotta post up my Spartan Race video, so definitely remind me. But anyway, today's poem is, oh yeah, I just watched the new Marvel movie, as you know. Guardians of the Galaxy or something. I don't know. It was fun. I always enjoy it. I'm not I don't ask for much, I suppose, but I also, it's fine. Anyway, today's poem is the number of subsequence that satisfy given some condition. The first thing I saw was mod, so I kind of did the mod thing while talking. What else am I doing? All right, let's actually read the poem. I guess that's what else I'm doing. But okay, so you're given an array integer nums and integer target. Return the number of non-empty subsequence of nums such that the sum of the minimum and the maximum elements on it is less than or equal to target. Since the answer can be too large, return it modulo 10 to the 9 plus 7. Okay. Let me reread this in a sec. The thing that I find a little bit annoying is that this can actually be a very good problem. But I do remember a little bit from yesterday, right, where we had a sliding windows, right? So which makes it, like I probably would think a little bit more about like dynamic programming possibly and stuff like this, and then think for a little bit and maybe look at the n, and n is 10 to the 5th. I'm like, well, n to the 5th, maybe not dynamic programming, but that minor I don't know if you wouldn't count it a hint, but that's kind of but it is a sort of thing that with the sliding window idea in the back of your mind, and then you just see the thing about minimum and maximum, then you know that that will probably be the case. In that, you just literally have a window of things or two pointer of things, right? And of course, in this case, if you think about minimum and maximum elements, then the first thing you want to do is sorting it. Well, the other part of that, of course, is that it's a subsequence, and in a subsequence, the order doesn't matter, right? It's just about the composition of the numbers, and therefore you can kind of reorder subsequences, right? That's kind of the idea to think about it. So okay, so the max element and yeah, and I think you can also you can also do a binary search if you really want to, but the idea is still a 2-point algorithm, which is that okay, you have some a plus b as you go or less than or equal to 9. So then as you increase one of your fingers, the other side has to go smaller, right? And of course that can be done in a whatchamacallit kind of way, on like a two fingers kind of way, which is fine. You can also do a binary search, which is also fine because you already do the sorting, so it's going to be n log n regardless, and you're going to be dominated on it. But in practice, it's a little bit slower. I wouldn't worry that much about it, but maybe Leetcode matters. And of course, for interviews, if you want to be just like, as precise as possible, maybe that's the way to go, right? But okay, so then now, yeah, after we sorted, we go maybe left is equal to 0, right is equal to n minus 1, right? And n is equal to length of nums. And then basically the idea is that while left is less than, well, maybe even equal to, right? So we want to make this inclusive, right? And then we set answer is equal to 0 for now. And then, okay, then what happens? I have to think a little bit about, what to do with duplicate numbers, but maybe that's fine. We just have to be, as long as we're consistent and precise, we should be okay. But yeah, but basically, if this is the case, we want to make sure that while num sub left plus num sub right is less than or equal to, well, if this is greater than target, we want right to decrement, and of course in this case we also want to make sure that left is greater than or equal to the right, and this case, and then we go right. So then if left is greater than right, then we break. Otherwise, then right is going to be right is going to be the last number, the index of the last number that that includes it, right? And I'm trying to think. So I'm trying to think about which one is more precise, is what I'm thinking about, to be honest. And both of these ways are they're very similar, but I'm trying to think about which one is easier to make mistakes. And this is basically saying there are two ways to count this, right? Or maybe more, but two ways that I'm thinking in my head, which is the sum of subsequences that includes left and right. And I'm trying to think about whether that is good enough. What I mean by that is that I'm trying to think whether there's an that means that given this bound, right, like the initial one bound, is it enough to just be 2 to the end of it, right? Meaning literally the power set or the length of the power set or the cardinality of the power set is sufficient, or whether I have to do like a sum while moving left. I think that's what I'm trying to prove in my head. Oh, no, yeah. It's definitely not the power set of that, because by definition, if you do not keep the min, and the min is not part of the set, then your max is going to get screwed up, and it's just not that power set. Okay, so now that includes the left and the right. So by definition, we include these two elements. But it's a little bit... you have to be careful here. So, okay. Actually, I want to change this a little bit. That includes the left. Sum of subsequent that includes the num sub left going up to num sub right, up to and including, but does not necessarily contain, right? The reason is that if we do not contain num sub right, it's okay, because if we do not contain the biggest number, the smaller number plus the num sub left is going to be good, right? So then basically now we're just doing ends is equal to something like this is so easy to be off by 1 that I'm trying to be a little bit careful. But so the number of things that starts from left to right inclusive, it's from left plus 1, because left has to be in there. So left plus 1 to right inclusive is going to be right plus 1 minus left plus 1. So then ends up being this. And of course, the power set of that number is going to be power of 2 to this. And then we just do it with the mod, and then mod it, right? Yeah, and then next we left increment by 1. I think this is roughly right. Maybe I'm off by a little bit. Let's kind of give it a spin. I do wonder, but it's kind of hard, to be honest, for a medium. That's why I'm like, maybe there's a slicker, faster solution, but maybe not. I don't know. Yeah, well, let's just give it Yoda Summit. Hopefully I don't miss any case. Looks good. Relatively fast, I guess. I don't know. What did I do last time? I did do the binary search last time. Okay, so I mean, it's fine. Yeah, but either way, both solution is going to be n log n because it gets dominated by this. And then here, as long as you do something, but yeah, and then this formula maybe makes sense, hopefully. And yeah, that's pretty much it. Yeah, let me know what you think. Let me know if I could clarify this a little bit better. But yeah, let me know in the comments. I am pooped. I am tired. So that's all I have for tonight. Let me know what you think. Stay good. Stay healthy to good mental health. Have a great weekend, everybody. I'll see you later and take care. Bye bye.